Okay, so 20 years ago, believe it or not, I was involved in taking some of our discoveries to try to develop therapies. One of our discoveries was isolating first the mouse and then the human blood-forming stem cell. That meant we had to develop a way to find that single cell of 100,000 in the blood-forming organ, to get that one out. And when we tested that cell versus all the rest, of 900, whatever it comes up to 99,999, we put those into animals, mice, that had the same thing as a radiation injury, like the bomb in Hiroshima or Nagasaki. And if you put in all of those cells except the stem cell, it didn't save them. But if you put the stem cell in, it would save them. And we did a clinical trial when we got to human, and we found that not only were they the only cells that could save irradiated animals that had their own blood-forming system destroyed by radiation, but that if we increased the number of cells we put in, we got a faster and faster recovery of the blood-forming system. So now we're ready to try it in humans. Women who have metastatic breast cancer have a death sentence. You no longer can do surgery locally anywhere. You can no longer point an X-ray machine and hope to kill all of the cancer cells. So that means you have to go to the much more difficult system of chemotherapy, where you have to use combination chemotherapy. Hold the recording for a second. So when we were able to isolate these blood-forming stem cells and knew that they would regenerate the blood-forming system after high-dose chemotherapy, we said, okay, let's see if we can save some of these women with metastatic breast cancer by increasing the dose of chemotherapy to the point that, at least theoretically, we might kill every last cancer cell in the body. The higher the drug dose, the more likely you kill them. So if you're going to go to that high dose to try to kill every cancer cell in the body, because a woman has about 10 billion cancer cells when they're diagnosed as a metastatic breast cancer, 10 billion. So we found that the blood-forming tissue from the woman that we would use to rescue the blood-forming system following this very high-dose chemo was contaminated with cancer cells. So her own cancer cells that would spread to the bones spread to the bone marrow. And when you try to get out the bone marrow or things coming from the bone marrow, you got cancer cells. So why would you take a woman next to death to get this high-dose chemotherapy, and their hair would fall out, they would have gastrointestinal symptoms? Why would you go through that if you're going to give cancer cells back in the body? So we found our method to isolate blood-forming stem cells depleted breast cancer cells 250,000-fold. That means that we could rescue virtually every woman who we were going to give this treatment to with their own purified blood-forming stem cells, but not if we gave back the whole blood-forming tissue that had cancer cells in it. At least that was what our theory was. And I can tell you that at the time this was happening, there was already a lot of unrest amongst the breast cancer doctors, oncologists, that the bone marrow transplant people were going to take over their patients, and they didn't want to give them up if they were going to go through all of this and it didn't work. So there was a lot of hostility to do this. So we did a trial that began in the mid-90s, and we rescued women with their own purified cancer-free blood-forming stem cells, and others at the same university hospital, Stanford, got the standard of care, which was rescuing them after high-dose chemotherapy with the cancer contaminated. And it takes a long time to see what happens in a trial. While that was happening, a very large pharmaceutical company promising to expand this to all the women on Earth, from the preliminary data they saw, paid a lot of money for it. So we go through the chemotherapy. Within 4 years of that clinical trial, the large company found it could make more money from something else that was easier to treat. And that was a big lesson for me, because I thought these companies were in it to save lives, but they aren't. No company is in any of these for-profit entities to save lives. It's just a lesson of capitalism, and capitalism is the only way that you get drugs to people eventually. So I took them at their word, and they stopped it. Meanwhile, I became head of the Stanford Cancer Center, and I told people we needed to go back and find out what happened to those women who were rescued with cancer-free stem cells versus cancer contaminated. And I'll just tell you, we saved 1/3 of the women who are alive today, 21 to 23 years later, with no cancer. The other 2/3, we extended their life with no interruptions for their cancer, on average, from 2 years with the standard of care to 10 years. So even those who weren't perfectly cured, we extended their lives with their families, without expensive care, and so on. I thought it would be a no-brainer that everybody would jump on it. But for a lot of reasons, they didn't. So it happened that when in 2001 and 2002, I was head of a committee of the National Academies of Sciences and Medicine and Engineering to look at stem cells and stem cell therapies and fetal stem cells and embryonic stem cells. We had a meeting. We described where we were. All of the experts in the field described, and there were some frauds and some experts and stuff like that. 2 days after our meeting, then President George W. Bush, just a month before 9/11, banned federal funding to make certain kinds of stem cell therapies available to people. So because I was ahead of the committee and I made the press announcement, all kinds of people started asking me, well, if the federal government bans this, the use of fetal or embryonic tissue to try to understand and treat people, what does that do for my kid with diabetes or my parent with Alzheimer's? I said, it stops it. And we don't know ahead of time what's going to be curative or not, but we've already got this strong evidence in metastatic breast cancer that you can think of pure stem cell therapies. So they got together, a couple of families who were in Hollywood. One made the old movie Airplane, and another one had kids with diabetes. So we organized, we discussed it, and we decided, as Mickey was saying, to take it to the people in California. Will you approve this kind of research? Will you approve the state funding the clinical trials as well as the research? And Proposition 71 did that, 59% to 41% in California, and put a lot of money in the bank to develop stem cells at all of the California institutions, to not be hampered by mainly religious bans or political bans on getting the fetal remains after an abortion, to be able to understand how the complex tissues of the body could be regenerated by stem cells. You're not going to get living people to do that. You're not going to interfere in the woman's right to choose and to make a decision what she's going to do. You're going to just treat the fetal remains as you would treat the donation of any tissue, which is legal. And we did that. And we made sure nobody made a profit. The woman, when she decided to have the abortion, was not educated as to what could happen until after the abortion. Then she was asked, the fetal remains could be used for medical research. And there's another thing called embryonic stem cells, which you get from in vitro fertilization. People can't have children the regular way. And in the test tube, they make a ball of cells following fertilization that would be an embryo if it was implanted in the uterus. And the way they do that at every one of these in vitro fertilization clinics, they get lots and lots of these embryos, of which they'll only put 1 or 2 back into the mother to have a child. And it was found that those ball of cells contain what's called embryonic stem cells, which haven't yet committed themselves to make a lung or a heart or a brain or any of that stuff. So they were called embryonic stem cells. If you took the discarded ones, clinic wasn't going to save them, cost too much money. It was only about money. So other people, not us, found that if you tease them apart and give certain factors in a test tube, you can grow up large numbers of those lines. And they stay at that very early stage unless you remove those factors and add others, and suddenly they make helter-skelter, brain cells, blood cells, a whole bunch of stuff. So that told a bunch of us that this was another way to try to get stem cells to treat people. But the Bush administration wouldn't fund it at the federal level anymore. And they certainly were against fetal tissue remains to make an advance. So that's why the people of California did it. In the 10 years, essentially, of funding that followed that, they were delayed 3 years by the political groups. They took it all the way to the California Supreme Court to try to block it. Many of those therapies are available and working. Many more are still in progress. California, with its 1/10 of the budget for even this kind of research that the NIH has got about 90% of the clinical trials going forward, or even things that advance much further. Last year, in June, against the advice of the heads of governmental agencies doing science, the Trump administration put a complete federal ban on the use of fetal tissues in research. And the same group, with backing from many people in Congress or the Senate, in the House or the Senate, have asked Trump in the next few weeks to ban all embryonic stem cell research. Our own fellows in our own lab, whose research was moving toward asking how do brain cancers form from brain stem cells, need to get at that type of research to know what they're doing. But they're blocked. We will go to jail. We'll certainly have our labs closed down if either of those federal government interventions work. In addition, just so you know the whole story, The federal government never tried to take a promising therapy all the way into clinical trials. They left that to the companies. But I knew when you leave it to the companies, you're forgetting about their motivation. They have to show their shareholders that they're going to make as much money as possible, as fast as possible. So that's the background to this movement. We now have in California probably 15 or 20 stem cell centers at academic institutions. All of them are doing research leading to therapy. Many of them use embryonic stem cells or fetal tissue, or have, which they're permitted to do in California if they're funded in California. But if Proposition 14, which is the follow-on to the old Proposition to 71, isn't funded, it won't happen. The same groups that are blocking fetal tissue research and were put in to review all former funded projects for the federal government that used fetal tissue and rejected 15 out of 15 because they don't think fetal tissue should be used. That's their right. Now it threatens completely, as even more than in 2004 when we had that first ban. But now there are lots of invested groups who want to block it. And they raise a lot of money. And they're going up against the politics of the Trump administration and the whole Republican group that back it. I'm not trying to get into partisan politics here, but all of us who train in science and use science for medicine take an oath, it's a derivative of what's called the Hippocratic Oath, that we'll do no harm and we'll do our utmost to advance medicine for the health of people. So we can't do it. The only way we can do it is if Proposition 14 passes. None of us make money out of this from the research we do, but we do advance things in clinical trials so that you get to the point that if a large company buys it or a startup buys it, it's now beyond risk. So they would have put in 150, 250, 500, up to $1 billion or up to $1 billion to make a product from the beginning. Now they don't have to do it and they can't claim that they spent that money to do it. As part of Proposition 71 and Proposition 14, we require not only could you carry the research all the way to get rid of the risk, that is, it is safe and may be effective, but that if you can't afford that clinical product that came from the state-funded research, the company who accepted money, the university who accepted money, have to offer it as close to cost as you can. So Bob Klein, who really brought this all together, has been a genius to figure out how you can make it happen. The people in the state legislature, like the people in the federal government, know that regulating money is power. So when Tony Fauci, for example, needs money for the COVID crisis, every year he has to spend time going to tell Congress what it could or couldn't do. And then they approve the budget that year just to keep him going. What Bob Klein figured out is that you need the stability of 10 years of funding that field to bring the best and the brightest into the field. So he made it a bond measure. 40 years to repay a bond to pay out for 10 years the amount of money for research. No interest on the bond until 6 to 8 years in so that you get a running start. And that's pretty clever. There's a lot of financial stuff I wouldn't pretend to understand, but it comes down to this. Once again, the federal government has stepped in to use its politics or its religion or whatever to block a line of research that is already proven to help people. There are a bunch of naysayers who've tried to block it. One reason or another, if you dig deep enough, you'll find out, but nobody's really digging. So we're there again, and now we're in a much more fragile political climate to get it going. Bob Klein and I, back in 2002, 2003, 2004, would go in front of large groups of potential donors to say, here's the story. And it's as long as the story I've been telling you. It's not so easy to get it across and keep it in lay terms, but we did it. And we got plenty of money for the ads to present the other side of the case. But in COVID times, you don't get anybody together. You set up a Zoom meeting and you're lucky if you have 10 people in it. So you just can't do that same way efficiently. But if we could get whichever way we can, the sense of the real story out, the fact that it has led, despite what anybody else says, clinical trials, more from the state of California than the whole United States funded by the federal government in stem cell related research. And that many of those trials now we've proven. So for example, one of the things we showed, started in 2009, is that we now have an antibody to a cancer stem cell, which helped remove that cancer stem cell. And we did it first with leukemia, acute myelogenous leukemia of the elderly, because they are not curable at all. And we figured out, and eventually it went to a company, that all of the patients respond, and at least half of them are now a couple of years out with no leukemia. A pre-leukemic condition called myelodysplastic syndrome. The older you are, the more likely you are to get it. If you had previous chemotherapy, you're likely to get it. Same 100% response. So they can't say that their way of doing things, mainly in commerce, or federal government, low amounts of money, but not enough to commit to try to solve the problem. They cannot say that's not true, even though they'll say it in their ads. They'll say, you promised us therapies. You know, you've had 10 years of our money. Where's the cures? So I'm going to make one final point about the cures and the time to the cures. If you look at any drug today, or any therapy, or any stem cell therapy that's approved to cure people, there's at least 5 years of deep trials to make sure you're not fooling yourself and that you're helping people. That's called a phase 3 trial. Then before that is another 3 to 5 years to make sure there's at least modest effectiveness along with safety. And then before that, there had to be 3 to 5 years of phase 1 trials for safety. What's the dose you can give safely to people, even though you don't know if you're going to cure that group of people. So that's at least 10 years, let's just say. Before that trial, that early phase trial, you got to have developed the therapy from the discovery. That takes a few years. Before that, the preclinical proof of principle you need to develop in small animal models. And before that, you need a discovery. So in 2002, 2000, 2003, and 4, I said in every place I went to a meeting, this might not happen for you. It's more likely to happen for your kids, and probably sure to happen for many of them, your grandkids. But if you don't start now, there won't be anything for your grandkids. And they'll go to the same old medicine that was taught in the 20th century, which is favored for a lot of reasons. So if you want to disrupt the system, you got to take this long bet. And what the people who are counting against and making ads against, they said, no, 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 you promised cures in 10 years. Well, I was the one talking. I know exactly what I said. Anybody who taped it would see that. So what they've done is they've created a straw man, which they can then tear down. But it's not true. We have warned people ahead of time, this will be for your children and grandchildren. And if you're amazingly lucky, it might happen for you. Every time a group delays progress from a discovery to something that will turn into a therapy, if they delay it and they'll say, for example, well, let's put this before a committee and we'll meet again next month. When I was in the room helping develop these therapies, I said, just a second. If you add a month, just a month, there are people downstream whose only window of opportunity to be saved was that month you just gave away. So if you're going to be serious about taking your discovery to therapy, you have to assume every patient is like your wife or your husband or your kid or your mother, your father, because if you don't have that urgency to your commitment to see if you can take it, you won't get there. So that's kind of the spiel. And any questions? Okay.
Allyshia, do you have any questions for Irv or for any of the rest of us that, I don't know, any thoughts based on hearing that?
I'd love to learn more about the solution and how everyday people like myself can present the solution to the public on any kind of form of social media or in person, whatever the opportunity looks like. And how do I speak to it? Because you've got years of experience and you're very tenured in what you do. And so hearing you speak for 30 minutes, I feel extremely moved. But how can I do it in such a short amount of time, perhaps 45 to 90 seconds, where people are really going to feel the impact and feel compelled to understand this issue as deeply as well?
I think one of the ways to do it is to say, California committed to try to take discoveries in stem cell research and bring them to therapies. Committed it back in the early 2000s. Despite what anybody else says who have their own motivation for saying it, it worked. But now it's going to end. And unless we have another 10 years, we won't be able to save the many, many people, even the ones that our little therapy did. Acute myelogenous leukemia, myelodysplastic syndrome, and breast cancer. In the US, 50,000 women a year get to that metastatic stage where it's spread. We don't save any of them now. We had the model, how to save them in a real human clinical trial, but it wasn't going to make money fast enough for whoever got it. So we're taking it back, which we did. We have it available. So those three examples are not theoretical examples. They're how you could save people now who have no chance. Everybody you talk to will have a relative who died of breast cancer or leukemia. Everyone. And you could say, well, it's sad that we couldn't catch these things in time for your relative or your friend. But we do have the ability to carry it forward, but only in California, only with Proposition 14.
So it sounds like a lot of the people who are against stem cell research are either politically against it or religiously against it. Are there ways that you can kind of mitigate and counter-argue those sides a little bit and kind of prove to them this is science, this is helping people?
Yeah. So the political religious side which will never change their mind, has to do with, did we make sure that in obtaining the fetal or the embryonic stem cell tissue, we didn't endanger anybody. We didn't incentivize anybody to do something different than they would have done. So we protected that side. And we made sure that nobody could make a profit from that. So you will never change those people who are against it, but you can explain to others that this is the way for it to happen. I'll give you one last thing, and I think Mickey can send you. I wrote an op-ed on human fetal tissue research. It was in USA Today about, 8 or 10 months ago. And it's a short op-ed, but it's very simple to say, there are far more discoveries that have been made with this research than you've been told. Here's some examples, and you can go look it up. But I would ask you, as an individual reading this op-ed, that if you are part of trying to ban this research, whether you do it through money, politics, law, executive ban, that you take the pledge for you yourself that you will not accept a therapy that was made through this kind of stem cell research. I wrote that and published it, about 8 months ago. Guess who the first recipient of research that probably saved his life was? From fetal tissue, Trump. The antibodies that he got that shortened his infection time, he got it, nobody else gets it, were made from fetal tissue.
You talk about that there's so many more discoveries that are actually made from this that people really don't realize. What are some good resources or landing pages that you can direct people to go to if they want to do their research and due diligence on all of this?
Yeah, we will supply you with the whole set of things that a group called Americans for Cures, a nonprofit group, has prepared for all of this. There is a longer documentary movie about this, which was made by a great documentarian, Joe Gantz, and he'll make it available for groups if they want to watch it, but it takes about 45 minutes for that kind of a thing. But the important part there is it's real people. 2 of the women that we saved in 1996 from their metastatic breast cancer, their doctor advised them not to go into the clinical trial because he didn't want that to happen. They never spent a day in the hospital for breast cancer again. When we had the reunion and talked to them, now 20 years later, there were a lot of tears because they grew up. They brought their children up. One was a teacher, 2nd grade in Milpitas. She had class after class. She taught. She brought up her children. It's that real set of examples of what can happen that gets to almost everybody. So we'll make it available for you. I'll even have Joe Gantz, if you wish, to say to a group, do you want to see this? I'll ask him to put it online and people could watch that longer session.
That would be wonderful. I personally I'd like to watch it. I think that sounds really fascinating. I think that's the best way of education too, is storytelling and having real people share their experiences, because you're able to connect. And I think it resonates so much better with people who haven't firsthand experienced the benefits of something like stem cell research. So I would really love to follow up with how I can get my hands on that documentary.
We'll get it to you.
Thank you.
So the other thing you can say when you talk to people who might be able to help in the next, if you meet any people in the next 10 days, that would help support the proposition, they can always, you can get them directly to me. You could say, I've talked with him. I know some of it, but why don't you talk to him? He's quite willing to talk to people in order to help us get over the hump.
Perfect. That's wonderful. And I'll just connect with Mickey then after all of this.
Yeah.
Absolutely.
I have some material that I can offer that I actually wrote because some people ask me, why should we pay for it? People are worried about the financial aspect as well, even if they're not religious. I don't know if you encountered people like that. They say, oh, research is great, but why should we fund it? Have you seen that? Did that happen to you?
Personally, not me.
No, well, I heard that a lot. And so to respond to those people, I said, well, first of all, because we want science in California to be strong and we don't want it to be dependent on religious opinions. We will continue. So we have enough strength here that we can continue regardless of what the federal government does with our budget as an impulsive, almost impulsive response to religious parties or people pressure, political pressure. Number two, there is a lot of advantages, not just potential. And Irv mentioned the treatment, new immunotherapy for cancer that's already proven itself in saving lives in clinical trials and will likely be approved within a year or two. Is that correct?
I think the two parts, the breakthrough trial is approved to go ahead. So a couple of years to make sure you analyze it appropriately.
But we already know, and it's already published, that lives are being saved through those clinical trials already. People with lymphoma who would have died otherwise are getting up and getting back to their lives. And I think it's incredible. And people can be very complacent until one day a diagnosis hits them and all of a sudden they become great supporters of research. Let's become supporters before we get a disaster in our own lives. Let's prepare for situations like that. So that's kind of like a life insurance, if you would. The other one is a revolution in stem cell transplantation, the preparation, the antibody preparation before stem cell transplantation. That blood stem cell transplantation that Irv developed and was the first one to do it is a stem cell transplantation. Irv, would you like to talk about that? Should I like to talk about that?
It's a little complicated, and I don't want to take more time than you actually have.
Okay. Well then,
I'll just say one small point about it. The bombing of Hiroshima and Nagasaki led us to understand radiation kills, and it kills by destroying blood-forming tissue. Physicians finally got smart to use bomb-like drugs and radiation itself to kill cancer cells selectively. And so the thing we developed, what I told you about with metastatic breast cancer, was part of that. So everybody felt in order to get a stem cell transplant, you had to undergo this next to death high-dose chemo or radiation. But we had found, in fact, in 2001, that we could block the development of juvenile diabetes by replacing genetically diabetes-prone blood formation with one from a family that didn't have the gene to cause diabetes. Same with a disease called lupus. Same with a disease called multiple sclerosis. Same with sickle cell anemia. Same with Mediterranean anemia. Same with diseases that affect millions of people. But you would never take somebody close to death if, for example, all they had to do was inject insulin many times a day, no matter how it changes, of course, their personal lives, which it does. So we found a way to replace radiation and chemo for those regenerative stem cell transplants by having a collection of antibodies we infuse in the recipient for a week, and it gets rid of the bad stem cells, it gets rid of the immune cells that would cause rejection. And it allows the stem cells to go in, which, by the way, we showed along the way, that we could do a heart transplant from the donor strain in a mouse that just had this kind of antibody instead of chemo. And the heart transplant recipient never had to receive any other chemotherapy for life. So this is a huge platform for regeneration or replacement of diseased organs, as well as what we've been talking about for cancer and other diseases.
Yeah, I can send more material about that and explain more if you like later. And then just about the money, I want to say that the way that the Proposition 71 was written, and I believe also 14, if a treatment becomes successful and commercially successful as well, if there's a new medication and there is high income from that, part of that has to go back to California and to the budget of California, and can be used by California in any way that the state decides. It's not just for research. Am I saying it correctly? Is that correct?
Yes, I tried to fight against them being able to use it for anything, because I thought if you make a discovery funded by California, the money should go back to the unit that could keep going and doing that. But
yeah, that was my assumption, but I didn't want to say something that's not correct. So I actually went back and read it, and I saw that it just goes back to California. But I think for Californians in general, it either way could be a selling point. Just say part of this money will go back. And this is a very long process, and you can't rely on, so people say, so why don't you go to private investors? No private investor will invest in a process that will take 20 years and maybe be successful. This is like paving roads or building the Bay Bridge. You're not gonna tell them build the Bay Bridge and maybe you can collect toll 20 years later and to cover the investment. This is something that is part of developing healthcare and something that governments do. And for the government of California, unlike the federal government, we will have income if companies are making a lot of money out of those discounts.
You look at the new Prop 14. Instead of that money just going back to the state for their general purposes, they were allowed to put into the proposition that a significant part of it could be to pay for the full medical care for those people getting the treatments.
Okay, yeah. So,
I didn't want to push that too hard because then somebody would say, oh no, that's like Obamacare, or that's actually like socialized medicine.
Advancing the health of the residents of California.
Yeah.
And lastly, we're talking about 30 years. We're talking about each one of us maybe giving up less than one burrito a year, less under $6 a year. And so that it's not that much for us as residents to, yeah, sure, I'll have one less burrito a year if I know that, you know, there's a promise that if I ever need or somebody I care about or everybody here, we will have better treatments and better medicine.
And Mickey will tell you all about Lyme disease.
Yeah, and one of the things, there's actually a whole bunch of people on this call right now, scientists in Irv's lab who have actually gotten their start through CIRM. So CIRM has been able to do many things directly in terms of, you know, advancing new treatments, but also in terms of training of scientists who may or may not have had that opportunity otherwise, giving them kind of, you know, developing these training programs that allow people to get this first experience into stem cell research, into different types of life-saving research, and then follow out, you know, a scientific career and see if research is for them, and in the meanwhile advancing these therapies. One additional thing I wanted to say about CIRM that I personally find extremely impressive is that as opposed to the, the way that the NIH, so we spend a lot of our time writing grants and trying to, get these approved by peer review and see what other scientists in the federal government or different review agencies that we send these to think about these proposals. And sometimes we get back proposals. I personally have had a few of these return where one reviewer loves it, absolutely glowing. This has to happen. This could change everything. And one reviewer, hates it, but really hates it, and is, this isn't worth our while. Triage this, and then you end up in this dilemma, and you get scored kind of in the middle. And a score in the middle is never going to get you funded. So if you send one of these grants to the federal government, and that's the kind of review that you receive, that's never going to get funded. One thing that CIRM did that I find very unique and very special is that CIRM specifically put in that grants with a large range of response between one reviewer to another. So if there's a large deviation there between how different reviewers scored it, that those grants now need to get an additional level of review. These are now reviewed by experts who, have taken on this mission to look at this more objectively and try to ask, okay, why did we get this love-hate review? What's going on here? Is this a promising idea? And that in itself has actually saved some incredibly promising proposals. Sometimes in research, sometimes we step on a few feet. Sometimes we, as we're blazing something new forward, we're saying that something old didn't work. There's sometimes hurt feelings, but I think it's very important to be able to then look at that objectively and say, why did somebody hate it? Does that really mean we shouldn't fund it? If somebody loved it, let's take another look. And so I think that's really powerful. And I also just wanted to open up to some of the CIRM trainees, former CIRM trainees who are here, who got their start through CIRM, and maybe hear a little bit about their experience and what CIRM has meant for them, and essentially Proposition 71, what doors that's opened up in their lives.
Yeah, so I I got my bachelor's at Humboldt State University. And I remember the first time I heard about CIRM, this internship talked about by one of my professors, stem cells, it sounds so impressive and so crazy to just kind of like the normal person. And I'm not some 4.0 student. So hearing about this internship, it seemed like this incredible opportunity, but something that I would never be able to compete with others going for it, right? But then the professor believed in me, as being his student, he encouraged me to apply. I applied, and sure enough, I got the internship, and learning about different labs and different research, chose to join Irv's lab and join Mickey's team working on infectious disease. And my past year here, now I'm an employee as a staff member, as a researcher, has opened up, it's taught me so much about healthcare and the medical community and the scientific community. It's allowed me to gain confidence in my own ability to do research and understand this world, and has encouraged me to want to become a physician. I love pathology, and diseases, from working with Mickey. And then I love, hematology, something Irv is so involved in. So if I didn't have this CIRM experience and this time at Stanford, I probably would never have thought I'd be able to go on to become a doctor, So in that sense, if other students who are funded by the CIRM program have the same type of experience, where then they get the confidence to go off to be, other scientists and doctors, well, now we have so many more doctors who have been trained in this important research who can help other people. So not only, does this CIRM program encourage research, but it increases the number, of people who want to become physicians and help, their community, which is really special.
That was really beautiful. Thank you for sharing that.
I was never a 4.0 student either. I came here from Montana State College, and there was no CIRM program, but I got in because of the research I did. Talent doesn't follow grades in research. It follows something else that's more creative. And so by excluding people who go to the wrong school or didn't get 4.0, whatever school they went to, you're losing some of the best and the brightest that will do it. This group is amongst the best and the brightest I've seen.
Do we have any other former CIRM trainees who wanna say something?
Yeah, so I also went to Humboldt State. I preceded Sarah by some years. I was probably somewhere between like the 10th and 12th generation of CIRM funded cohorts to transition from Humboldt State, which is such a small university, to these really amazing institutions. Humboldt State in particular, the way their CIRM funding works is they have relationships with Stanford, UCSF, and UC Davis, which are all incredible institutions in California. And this funding, it not just bridges students from this small university to these great places where you can really get your feet wet and really be exposed to some of like the leading technology and brightest minds in the world, but it actually also started the program at Humboldt State. So I got my bachelor's and my master's degree both at HSU. And the lab that I worked in, we had this teeny tiny little like closet-sized tissue culture room where you could learn how to culture stem cells, you could learn how to do different assays and things. All of that equipment came from CIRM money. So we started from absolutely nothing at Humboldt. And CIRM built us a tissue culture room. CIRM built us a lab where we could learn molecular biology. And then CIRM built a program to advance its students from all sorts of different stages of academia and get us into these really incredible positions. And so I've been at Stanford for almost 4 years now. And in those 4 years, my first year was CIRM funded, and I was able to work with this really incredible investigator who was a former PhD student in Irv's lab, Charles Chan. And I got to be part of a team who characterized and published on the discovery of the human skeletal stem cell. Huge, amazing, once in a lifetime opportunity for somebody who came from a tiny university and probably could have never imagined being a part of that. And since then, I've transitioned and I'm now a technician in Irv's lab and have been for a little over 2 years now. And I've transitioned more towards cancer biology, but having gotten my start in my master's in stem cell biology, it's just everything from my professional life over the last like 6 to 8 years came from CIRM. And it's just an unbelievable opportunity that everybody should have.
I am very moved by Rachel and Sarah's memories of Humboldt State. I also went there. Sarah actually was my partner in the tissue culture hood at HSU. In that little hood where you put as many students as possible and you learned how to culture mouse embryonic stem cells. And I first learned about this program when one of my TAs in my genetics class actually was taking the stem cell class, and they were culturing mouse heart muscle cells that they beat in the dish by themselves. And he said, "Do you want to come see this?" And I said, "Yes, of course. Oh my goodness, you have cells that you are growing in a dish that are moving by themselves. This is incredible." And so I went there, and that stuck so firmly in my mind that it was amazing. And so when I applied for the CIRM internship, I just felt absolutely so incredibly blessed that I got that chance to come to, again, Irv's lab, and just really, off of what Rachel said, really just run with all of the new things, all of the equipment that we had only read about at our small state school up in very Northern California. Learn all these different techniques and really just open so many doors. Oh my goodness. You think about things in such different terms now, and it really is incredible, my experience with CIRM. Definitely feel very grateful for Prop 71.
It's so incredible hearing all of your stories, because I think it helps bring so much color to the photo and the overall picture, for me at least. And it sounds like Irv has made quite an impression on all of you, and myself as well. So thank you so much for being here and being so so kind to just dedicate your time and believing in all these students who have consequently now made such an impression on myself. So I'm feeling very grateful to be connected with all of you, and moving forward, staying connected with all of you as well.
Well, thanks for taking all the time. Mickey, some last words?
Yeah, so I think in terms of last words, what I would like to say is that the level of research that I'm seeing at Stanford personally is incredible, and driving through progress and life-saving research that I have seen incredibly propelled forward by CIRM and by California. And for me, it's just such a pleasure to live in a state where we're taking this on ourselves, and we are, you know, not just saying, oh, the federal government won't do this. We're taking action, taking it into our own hands. And I really, really tremendously hope that those of you who, you know, anybody who's listening to this and, you know, was on the fence about Prop 14, I hope that this gave you a new light in terms of thinking about it and what this means for us who are doing the research on the back end, and what this means for you.
Great.
All right. Thank you all so much.
Yep. Thank you. Nice to meet you.
Thank you, guys.
Bye. Thank you.